partial derivatives. Say we have a function z, which is a function of x and y. This example could be x squared plus y squared. Oops. So what we want to do is we want to find the partial derivative. So to do this, we're going to fix one of the variables as a constant, and that will then we can differentiate with respect to the other one. So if we take the partial derivative, and this is a function of xy, then the partial derivative with respect to x is the limit as h tends to 0 of f of x plus h y minus f of x y all over h. And that is exactly the same for the partial derivative with respect to y, except from we have f of x y plus h minus f of x y all over h. So how do we calculate this? So before, when we're standard differentiation, we have our limit definition, and then we know that to differentiate something like x squared, it becomes 2x. So for partial differentiation, say we take z equals x squared plus y squared. If we differentiate partially with respect to x, then we take y as a constant. So y here is going to be 0, and we differentiate the x to 2x. In the same way, partial derivative of z with respect to y is 2y. What about something a little bit more complicated? So say our f of xy is equal to x cubed y squared minus 2x squared y plus 3x. Here we can take, if we're going to find the derivative with respect to x, then y is going to be a constant, y squared is going to be a constant. So that will give us, we take the derivative of x cubed, 3x squared, and then we multiply by a constant, which is y squared. And then again, take derivative of 2x squared, which is 4x, multiplied by a constant, and then the derivative of 3x, which is 3. If we wanted to find the partial derivative with respect to y of the same function, again, we would take our constant, which now is going to be x cubed, and then times by 2y minus 2, our constant here is going to be 2x squared, and y just differentiates to 1, and then our constant here is 3x, but there is no y term, so that vanishes to 0. So another way of writing a partial derivative, so with our function f of xy, the partial derivative with respect to x is equal to del by del x of f, or del f by del x. Note that this is del and not d. D implies a complete differentiation. And the same thing here for partial differentiation with respect to y is del f by del y. And I believe that is partial derivatives. Thank you for watching.